Hello everybody, yours Mathemagic here, back again with an amazing question which is also an RMO question which came in the year 1991. The question reads, prove that n to the power 4 plus 4 to the power n is composite for all integer values of n greater than 1. Well, this is a pretty easy question, and the basic approach I think is at first to consider two cases, case 1 and case 2. Now, what are these cases actually? So, for case 1, we will assume n to be even of the form 2k, and for the second case, we will assume n to the odd as 2k plus 1. Now, we all know that n can either be even or odd. So, first approach with the even statement. Now, notice I can replace n with the form 2k. So, according to case 1, 2k to the power 4 plus 4 to the power n. Now let's leave this part as n, but notice and focus on here. We can say that 4 divides 2k to the power 4, and also 4 divides 4 to the power n, because n is not 0 and it is greater than 1, so obviously greater than 1 or greater than equal to 1. So I just verified whether I was correct or not, and it is obviously correct that n is greater than 1. So here we have 4 belongs to 4 to the power n, and also 4 belongs to 2k to the power 4. So divisible by 2k to the power 4. What am I saying? Well, I'm trying to tell you that 4 is a factor of 2k to the power 4 and also 4 to the power n. Now, for here we can say that 4 divides n to the power 4 plus 4 to the power n. Hence, this is obviously not a prime, because for 4 and n to the power 4 plus 4 to the power n, we have a GCD equals to 4, which is obviously greater than 1. So, basically, the first case is proved. Now, coming to the second case. Now here we need a little bit of knowledge of a formula. So what is the formula says is a to the power 4 and 4b to the power 4. So if we get any formula of the form a to the power 4 plus 4 to the power b to the power 4, then we can say that for this kind of formula we can write this as, notice I can write it a squared plus 2 plus 2b squared whole squared, right? Now let me take a 2ab form. So I have 2, then a squared, then times 2b squared. Now notice this is 4a squared b squared, so I have a minus 4a squared b squared, right? So this can be written as here, and here we can write this as a squared plus 2b squared whole squared minus 2ab whole squared. Now this is of the form a some squared minus another squared, so we can again write this as a squared plus 2b squared plus 2ab times a squared plus 2b squared minus 2ab. So basically what I'm trying to say and I'm trying to prove is that any number of the form a to the power 4 plus b to the power 4, where a and b belongs to some positive integers, this is always a composite number. Not only that, this is means true for plus 0 also, I guess. Yes, because you notice that for a to the power 4 you can a 0, if you put it, is coming as a composite number, but both cannot be 0 at the same time. So now notice that if I write n to the power 4 plus 4 to the power n, it is more or less looking like a to the power 4 plus 4b to the power 4, except the fact that we should have b to the power 4. Now notice I can write this n as 2k plus 1 if it is odd. So just that only I will do. I can write this as n as n to the power 4 plus 4 n to the power 2k plus 1. Now this can be written as n to the power 4, 4 to the power 2k plus 1. Now this can be written as 4, now this one I can write as 4 times 4 to the power 2k, which can be written as 2 to the power 4k. And we are done. We can write this as n to the power 4 plus 4 times 2k to the power 4, which is nothing but of the form a to the power 4 plus 4 b to the power 4. And thus we are done, and we can just write about this formula and prove it. So that was all for today. Thanks a lot for watching. Goodbye.